Welcome to Cypress's Spread Spectrum Training module. My name is Prasad and I am Product Manager at Cypress Semiconductor. In this module, we will cover what is spread spectrum and how it will reduce EMI. What is EMI? EMI stands for electromagnetic interference. It happens due to unwanted radiation generated from an electric circuitry. The main source of EMI is faster edge rate and higher drive levels. Such radiation can result in malfunctioning of system as well as in some cases destruct the whole system. To avoid such kind of accident, FCC has defined maximum allowable radiation level in specific range of frequencies. These limitations are defined based on usage and the functioning environment of the equipment. There are three well-known techniques. First one is called the suppression or filtering. In this technique, we essentially add a filtering circuit such as a capacitor to the output of the clocking signal. The advantages of using such techniques are: 1. It's a low-cost solution. 2. It does not change the clock accuracy. However, this technique offers many disadvantages. First one, it's not systemic. That means filtering is required at all emission points. Second, it leads to increase in the rise and the hold times. The second known technique is called a shielding or containment. In this technique, we essentially add a ferrite bead or a choke for EMI reduction. The advantages of using this technique are: 1. It helps reducing EMI at a higher rate. 2. It does not change the clock accuracy. The disadvantages are: 1. It's not systemic. 2. Difficult to incorporate into automated production process. 3. It's expensive. The third and the most effective technique is called as the spread spectrum technique. As shown in these images, in spread spectrum technique, signal energy is spread out over a range of frequencies rather than concentrating it at the signal frequency. This energy spread is achieved by modulating high signal frequency at lower frequency signal. The advantages of using spread spectrum technology are: 1. Spread spectrum technique is systemic. That means the EMI is reduced at the clock source itself. 2. Clock rise and fall times are not changed. 3. Modulation is above audio range, eliminating audio interference. 4. Spread percent can be controlled with ease, leading to direct EMI control and optimization. The disadvantages of using spread spectrum technology are: this technology cannot be used at higher accuracy clock and as well as synchronous clocks. In spread spectrum technology, modulation signal is added into the feedback path of the PLL as shown in this diagram. The profile of the modulation signal plays a vital role in resulting radiation reduction. There are two well-known profiles. First one is called the linear or the triangular profile. The second one is called the lexma or the Hershey's kiss profile. As shown in the graphs, the linear lexma distributes energy over a higher range of frequencies as compared to the linear, and hence is preferred profile. Cypress has a patented lexma profile. Spread spectrum has two major parameters. First one is called the modulation rate, which is relative variation in the output frequency resulting from spread percent. Higher the modulation rate, greater is the peak energy reduction. Typical modulation rate is for center spread is between plus or minus 0.5% to plus or minus 2.5%. For down spread is between minus 0.5% to 5%. The second important parameter is the modulation frequency. Modulation frequency is defined as the frequency at which modulation profile is repeated. The typical modulation frequency is between 30 kHz to 120 kHz. This graph shows the plot of modulation frequency versus the modulation rate. There are two types of spread. First one is the center spread and the second one is the down spread. Down spread is used for applications where nominal operating frequency is the maximum operating frequency. Center spread is used where the maximum and the minimum frequency will be high and low as compared to the nominal frequency. This graph essentially plots the spread percent versus the EMI reduction. It's very conclusive from the graph that a very small spread percent causes a large reduction in the EMI. Just to summarize the key benefits of spread spectrum technology: 1. Peak EMI reduction on each harmonic. 2. Programmable EMI reduction and functions. 3. Frequency synthesis helps to eliminate higher order expensive and unstable crystals. 4. No degradation in the rise and the fall times. 5. Faster time to market. 6. Reduction in the product development and the manufacturing cost. Lastly, reduction of PCB layers leading to additional reduction in product cost. Now we will walk you through the Cypress EMI reduction portfolio. Cypress offers a very broad portfolio in this family. It offers from 1 PLL to 4 PLL. It supports up to 9 outputs. The maximum operating frequency is up to 200 MHz. The operating voltage is between 1.8 volt to 3.3 volt. Our CY2570 family comes in the standard LCC package and is a direct replacement for many crystal oscillators. The application in which EMI family can be used are multifunction printers, VoIP routers, digital media camera, mobile phones, car navigations, test and measurements, routers and switches. This ends the training on spread spectrum module. For additional support, you can visit our website www.cypress.com/support. Else, contact your local sales representative or authorized distributor. Thank you.